We are live now. Welcome to Planetary Health First, Mars Next. It is going to be an amazing journey today. Hope you are ready for liftoff. We are live now. Awesome. Well, everyone, this is a great day. We have an amazing guest. But before we go into, I am Michael Mann. I'm the host of Planetary Health First, Mars Next. I'm the managing director of Desanti. And we have an amazing guest, Lox, who is a cloud solutions architect. Lox, before we go doing a deep dive, tell us just a little bit about you and your background, which I think is really important as you talk to our guest about this subject.
Sure. Thanks, Michael. So, hi, everyone. Sundararajan. I work as a cloud solutions architect. I've been in this industry for close to 20 years now. And when I started back in the days, cloud was still pretty nascent, but now you can see pretty much cloud is everywhere. So I've architected large, complex solutions in the cloud and with a lot of experience in the payer space. Kind of started in the healthcare space when we started deploying applications to the cloud, creating the omnichannel experiences all the way into leveraging AI for some of the healthcare operations that we have today.
Well, awesome. Well, we're going to be doing some deep dives today into generative AI in the payer space. We're really excited about this. I hope it's not just hype. There is talks about the AI bubble, the generative AI, but I think we have a long wave. And today we're going to learn a lot about generative AI in the payer space. And can you give us a little bit, just what this is, generative AI, what it isn't, Lox? Just give us some starting points.
Sure. So we have had artificial intelligence machine learning for a long time. And we have created machine learning models that kind of cater to a specific need, be it fraud detection, be it anomaly detection. There were machine learning models already in place. But recently, with the cost of silicon going down with Moore's law, what we have done as a new subset of artificial intelligence called generative AI has emerged, where we started creating really large models. When I say large models, to the tune of billions of parameters. And the model was not trained on a particular task, but it was trained on a bunch of tasks. And what it could do is it could generate new content based on the existing content that it's been trained on. It could generate new images. It can answer questions that you see today. So all that started emerging. Then basically, it's like a subset of AI, which is much more advanced because of the invention that we have with respect to the size of the model that we're able to create.
Awesome. Well, should we talk a little more about this, or should we begin doing some deep dives within some applications areas that generative AI can be used in the payer space?
I think we can talk a little bit more in terms of how this is basically making it possible. So if you look at it from the generative AI point of view, the underlying model that we have in the case of ChatGPT, the most popular one, they call it GPT 3.5. So it's been trained on billions of parameters, and it has been trained on a lot of knowledge sets. What that means is when you ask a question, it is able to predict the next word that comes out, and that's how it's able to generate the content. For example, it will start asking questions like the capital of USA is, what's going to be the next possible word. So that's how it kind of starts generating all this content. And there are models that let you generate new images based on the existing images that you have been trained on. And there are some models which let you summarize the text, which based on its ability to go through all the documents. So if you have like a large PDF and you want to kind of quickly know what is there in the PDF, you can ask a trained large language model, hey, can you summarize this PDF for me? It'll go through the PDF. It'll give you a quick summary saying that this is what has been there. That's because it has been trained on millions of documents and it knows exactly how to summarize the documents without giving it the same task. And that's where it excels in getting you the output. So the capability of the large language model is, since it's been trained on a really large data set, it can do some of the tasks that are repetitive in nature pretty efficiently and start thinking like human at times.
Wow, I need this. I'm reading a lot of PDFs, and um, it's um, it's pretty impressive with the amount of the capabilities that's possible. Just from a general standpoint, what are you really hyper excited about, not just in the payer space, but just generally with generative AI? Where do you see the opportunities in the next year or two?
See, the good thing about generative AI is with all these models that's made available, it's not just one model. There are tons of models that's available in the industry today. Everybody has their own model. If you look at it, so you can take any of the models, and there are a number of techniques available by which you can feed in your data set and get the required output. And there are multiple stages of training the model. So when I say you don't have to create your own large language model, there are techniques available starting from prompt engineering to tuning, which will let you get your output with minimal effort, both in terms of cost as well as time to get to do your tasks. So whatever you thought was going to take a lot of time is going to take only a fraction of time in terms of tuning the model. And you can start automating some of the tasks that you thought needed a human in place. So it's kind of going to help you do some of the tasks more efficiently so that you can have your workforce focus on the most productive tasks.
I can only imagine, though the possibility is so near, the massive amount of training the workforce on how to use the right solutions at the right place, right time, the upworking, the upskilling of the workforce. Can you tell me what's going on right now that you're seeing with that?
Yeah, I think that's a good question because if you look at the way generative AI has evolved, there's a lot of things out there. So people are looking for ways to get started. Like, how do I get started with Gen AI? Like, what does it mean? If I want to basically have my internal chat GPT for my organization, if I want to have my large language model that I want to host within my organization, which I don't want the data to be exposed to the outside world, how do I go about it? Those are the common questions that we have seen everybody ask these days. So to do that, I think the way you want to get started is you look at all the models that's available in the industry right now. You can pick any model depending on your use case. Like if you want to do a text summarization, you pick a model which does a text summarization, something like Llama or Anthropic. You can pick any model like that. Or if you want to generate images, you can pick Stable Diffusion. So you pick the model that you want, and then you can basically start playing around with it by prompt engineering. So prompt engineering is basically an example, like if you go online and type in a question to ChatGPT, ask any question, that's prompt engineering. So with prompt engineering, you can basically get some of the basic questions answered. But then if you, as an enterprise, if you want the model to react to your data, you have to do a little more work in terms of taking all the data, converting it to something called vector sets. Vector embeddings is something that's like a format that encodes the data which the model can understand, and it can add it to its own corpus so that when you ask questions related to your enterprise, the model knows where to look for and give you the data. So you create vector embeddings of your data, train the model, and there are multiple efficient ways of training the model. So you don't have to train the whole model because the model has already been trained. So you only train certain parameters, and then you make it available within the enterprise.
Are you starting to see in your industry new roles emerge with generative AI?
Yeah, definitely. What we have seen in the industry is if you look at some of the use cases in the payer space, be it fraud detection. Fraud detection means looking at claims that are fraudulent. How do you analyze the patterns and stuff like that? We already had machine learning models that were in place. But with generative AI, what is happening is instead of running these models and getting the data, people have started conversing with the model and just asking questions like, can you look at my data and tell me what the fraudulent claims are? Then it's going to basically look into your corpus and it's going to tell you, hey, these are the fraudulent claims. And then you ask more questions like, okay, so why are they fraudulent? It's going to converse with you and tell you that, hey, this is basically why it's fraudulent. So things like that, you're taking it to the next level, which means that's where we are having a lot of requirements where people understand the space and they can translate the industry requirements into generative AI use cases and then implementing the similar solutions for that.
Can you share a little more about fraud detection with AI, generative AI?
Yeah, so fraud detection has been there for a while, at least in the payer space. If you look at it, what you're looking at is analyzing the patterns in the data, and then you're figuring out where the claims are fraudulent. And we're using traditional machine learning models for identifying that. With generative AI, the way the fraud detection happens is going to be the same. The underlying algorithm is the same, but the way the user is conversing with it is different. So in the old days, what used to happen is your machine learning model that runs fraud detection, it's going to create an export of all the fraudulent claims, and somebody's going to review it and say, okay, these are the claims that are fraudulent, and they're going to take necessary action. Or automated workflow will take care of it. With generative AI, you can actually have somebody converse with the system and ask questions, and it's going to answer it for you. And another example I can think of is similar example is population health management. So in population health management, if you go to a payer or provider, they look at their corresponding risk cohorts, and they're going to tell you, okay, in my population, these are the patients who are at high risk. They're going to show you visually. But then with generative AI, what you can do is you can converse with the application. You can say, you know what? Can you look at my population and tell me which patients are most risk averse? And then you can ask questions like, did this patient take the medications? What is the average cholesterol for this patient for the past year? Stuff like that. And you're going to get ready-made answers by looking at your data.
Can we get a little more into fraud detection? Can we go back to that? What are we currently doing? What were we doing at the payer space prior to this? I know this is a huge area with CMS, with Medicare. There's so much that's going on. Tell me just a little bit, what was the prior background of how to detect fraud in the payer space?
So the prior way of detecting fraud was looking at all the claims and look for certain patterns to see whether the claims kind of originate from the same provider for multiple amounts within a short period of time and stuff like that. There are multiple patterns that are being looked at. And by looking at the patterns, then they start digging into the medical history of the patient, whether the patient really had the condition or was it basically treated for those corresponding codes. Was there any fraudulent cases with respect to the billing? Because you can only bill for certain CPT codes and there's a certain amount that you can bill. So all that is being analyzed. And that's what leads to basically the payer can kind of go after the fraudulent claims and get their money back. And in some cases, they have to basically work with the government for risk adjustment. And that's where the fraud becomes a bigger role as well, because if the payer has to prove that they are spending so much dollars on the particular patient, that's why they need more from Medicare and so on. So that's where I think fraud detection is pretty important.
So I would be concerned that the smart actors, if you would, that are the hackers, right? That hack, healthcare, right? Healthcare medical records, because there's so much that they're going to be getting access. And I don't mean to get off topic, but I imagine they're going to be getting access to a lot of these generative AI tools. And it's like a cat and mouse. Is there concern to that as well?
I think that could be addressed by securing your application, because the generative AI interface at the end of the day, it's like your web application that you'll not expose to everybody. So if you follow the enterprise best practices and
no, what I'm meaning is they're using similar technology tools to understand the sort of maybe not on a technical level per se, like what generative AI is being used to be more effective in traditional fraud detection, but I'm curious if the bad actors, if you will, because they're really good at filling out paperwork. They're really good at committing fraud. I mean, in some cases, they do the paperwork, from what I understand, they do better than the actual provider. So maybe that's an area when it's filled out too good, maybe that's an alert. I don't know. I'm sure there is some of that. But I guess what my question really was, so if there's, I imagine there's potential, just like we have been hearing with AI, for bad actors to use that. So that was what I was meaning, more so not like getting into your system, but using their own built out systems with generative AI to be better, just as good as you are at detecting as they are to prevent from being detected, is what I was trying to say. Does that make sense?
That's actually a pretty good question. And if you look at it, yes. I mean, if you know the system, you know what you need to fill out, and an AI can do it for you, then it can make it look like it's real. I think that's what the term we call as hallucination in generative AI. For example, if you ask a question for a model, the model doesn't know the answer. The model will start telling stuff that makes it look real. So that's called hallucination. So similarly, if the fraud actors know what are the fields that you need to give to make it look real, they can actually hallucinate and make a claim look like a real claim. And that's going to be a challenge. And I think that's there everywhere, even today, that you can make it happen. But that is basically going to be a big challenge for this, because it makes it easier for the AI systems. If you're a bad actor and you know what you're doing, yeah, you can basically start doing bad things.
And then I guess also currently, I mean, I guess the other thing is it's not just existing doctors and providers, it's the actual ones that open up rapidly, continue to open up new practices just for that. And I don't want to make it sound like I do this. I don't. I'm just a curious mind. So I'm just a host, a podcast host. I have nothing to do with this anyway. Just curious. So I'll stop at that. So maybe we should move over to risk assessment and another topic, unless there's anything else, Locks, that you would think would be important with fraud detection with generative AI.
I think the fraud detection, as I said, the enhancement that generative AI gives us, it can basically look at your enhance, basically make it more conversational, and you can kind of make it available to actors at a level higher than what you were before, so that they can kind of look at your data directly. Because previously they used to look at some dashboards and said, oh, these were the frauds that were processed. Now, rather than merely looking at dashboards, they can actually start interacting with the application and get more insights rather than having to go downstream.
Okay, so I get it. So you're really empowering those individuals that would be using less tools that aren't as effective. So it's really real-time tools to really get them smarter and smarter. And that to me does sound exciting for workforce, and then just anyone who's in the payer space to actually less frustration, maybe job satisfaction as well, that they're able to not have to be waiting. A lot of these things like claims are 90 days, look back. So now you're actually predicting some of these things. Is that correct too?
That is correct. I think if you look at it, for example, a manager who basically looks at the reports end of the day and says, okay, out of the claims, the fraudulent claims is X. Then, okay, so these were the fraudulent claims. Let me take a look at what actually happened, why it's fraudulent. They have to dig deep into the report. So instead of doing this dive deep, you can start chatting with the system like a human, just like there's somebody in the office. You can ask, okay, so you're saying this is fraudulent. Can you explain me why it's fraudulent? Then the system is going to say, it is fraudulent because these CPT codes, you can charge only X amount of dollars, but they were charged so much. And then you can say, this facility used to submit claims worth only $10 million, but now this year they submitted claims worth $100 million, but the patients didn't increase. So they basically, it can start chatting, having conversations with you just like a human. So you don't have to basically start diving deep into the reports.
Where is the majority, 80, like Pareto's law, where is 80% current healthcare fraud coming from, if you would?
That's a good question. I mean, if you look at it, it's a mixture of basically the CPT codes, where using the wrong CPT codes for basically the corresponding procedures, or it could be basically putting different kind of diagnosis, because the patient has been diagnosed for a certain list of diseases, but then you can see the claim coming for totally different kind of things that's going on. So things like that, that's where I think most of the stuff happens.
So like if you would, with the CPD codes, maybe some what we call risk adjustment upskilling, like basically, they have condition X, but then they're being charged for a more cumbersome, comprehensive procedure when it's not being done. Kind of that kind of stuff.
That's one of the things. The other one would be risk screening. I mean, the other one, I wouldn't call it a fraud, but that's risk assessment. Is, let's say somebody is screened for pre-diabetes, then they have to go through certain evaluations or certain blood work. If that's not happening on time, that's risk assessment. That's a different thing altogether. Yeah.
Okay. Well, do you want to? I know we had some stuff that we talked about prior to going live. Should we go to some of those areas like risk assessment or prior authorization or customer service, population health management? Or is there anything that you would like to talk about next?
Yeah, we can talk about prior authorization because that is kind of picking up pace, and that actually with the regulations mandating that prior authorization be supported in the future. That is actually kind of picking up quite a bit of pace. So prior auth, just to explain what it is, right? So you go to any provider's office, they just check your insurance information, and then they kind of start the treatment. And after that, you get your claims, and they say that this is your deductible, this is your payment, this is what you owe, and stuff like that. In some cases, you may be surprised that, hey, my deductible is so and so, but I'm being charged X amount of dollars. So stuff like that. That's where prior auth comes in. So the basic technology behind prior auth is pretty straightforward. If you go to any office, they are going to send a message to your insurance provider saying, hey, I'm going to treat so and so for this particular CPT code, and I'm going to basically charge you this much. Can I go ahead with that? And if they get the communication back saying, yeah, that is allowed, and the communication is established, then the prior auth is kind of done. And that's prior auth at a 101 level, right? And if you look at it, it's primarily establishing the communication between the payer and the provider with a secure channel. And AI comes into picture because you can basically automate by looking at the patterns, and some of it you can actually try to automate the approvals. So that's where kind of AI comes into picture.
So I guess the other concern is when you don't get prior authorization, I guess that's the careful element, when you're having a machine generative AI that's not allowing someone to have the care that they need. How do you do the best job to make sure that someone who's being denied prior authorization isn't being denied by generative AI?
Yeah, so that's again, if you look at it right now, prior auth is not widely implemented at all providers. So if you go to a normal provider, chances are very good chances that you don't get the prior auth. You just check for the insurance information. So the care given will still be the same. Prior auth is just going to make sure that you're not going to get any surprise billing at the end of the day once you're being treated.
So what is the problem right now? Because all I hear about is frustration from payers, or more so from patients and providers, about this whole rigmarole, really cumbersome process for prior authorization, kind of impeding the care. But I imagine, with all fairness, somewhere in the middle, right? The payers are looking after all the money, that has to go out for claims and care. So I imagine that's the biggest challenge. Everyone, wants to be careful until it's their family that has some severe cancer or whatever. They want everything that's possible. So how do they currently, tell me a little bit about that process right now, the whole prior authorization process. Of course, this is just one little segment, but just if you can tell me a little bit right now.
Yeah, sure. So if you look at the healthcare industry, I think the technology has been quite a bit of challenge in terms of adoption. Because if you look at it, electronic health records, if you see, there are primarily three vendors who take up close to 80% of the space. So that is kind of standardized. And recently, if you see, there's the CARES Act as well as the HIPAA Act that came some time back, ensured that there's a standard for exchanging information in the healthcare space, which is FHIR. So the data standard is kind of there when it comes to exchanging information. But the challenge is, with all the providers that's out there, can they basically transmit the information seamlessly between themselves and the payer? So an example I can give you is, let's say you are in New York and you go to a doctor, and then you have a medical history, and they pretty much maintain all your records. And let's say you move from New York, you go to some other place. Let's say you go to California, and then you go and see a doctor. All your medical history has to be transmitted seamlessly so that the doctor knows about your conditions. And you'll be surprised that 80% of the transactions like that happens through fax or paper. And then there's a process of feeding it back into the system. There is no electronic exchange that seamlessly happens between multiple providers. So that's a big challenge. And the same happens when you switch insurance. Let's say you go from one provider to other. You have a bunch of conditions. You've been assessed for certain treatments, you have been taking some drugs. So all that information doesn't just automatically move from one to other. There's a lot of behind the scenes stuff that happens to make the information move seamlessly from one payer to other. And that is because the way there are multiple data formats in the healthcare space, and that's what is being standardized through FHIR format right now. Even though that's there, the adoption is still not there yet, where you have a universal platform where the data is seamlessly exchanged between payers and providers. That's the holy grail that everybody has been trying to solve. That's why the challenge is for the payer is the payer wants to know what the patient history is, what is they being treated on, what are the conditions, so that they can kind of make sure that they are taking the meds, they are getting the treatment, and so on. From the provider point of view, they want to know the medical history of the patient so that they can give them better treatment. And that all that is being hinged because the data is not seamlessly transmitted between the providers and between the payer and the provider. And that's the biggest challenge for prior auth. How can technology help the data to be seamlessly transmitted? That's the biggest challenge in healthcare today.
Yeah, I think you bring that up really well. And then I'm thinking of the actual reimbursement too, with the amount of time. So it providers 15 minutes there with someone, patient, all these things that are supposed to be right aren't going to get done, because they're just doing whatever they need to do to get paid, to get, their ICD codes. And so I imagine you're getting poor information to begin with. Just because of the process. It seems like it's not just the technology process, it's all the other workflows. And then, of course, the other challenge is just the lack of sharing. When you come to those big, don't want to mention the EMRs that don't want to share. And so anyway, so to get back to generative AI. So let's just, if you could, I think you really gave us some good insight to the current challenges with prior authorization. Tell us what makes you excited with generative AI, how it can really help this pain point.
The generative AI point of view, when it comes to prior authorization, it's still a machine learning problem. It's not a generative AI problem. But again, the way generative AI fits in is it's going to let the provider automate some of the tasks that were not possible before. The provider can start conversing with the system, saying that, hey, connect me to the payer to get the prior auth. The process that happens is still the same, just that this generative AI is going to be like the voice of the customer, and it's going to basically do the stuff behind the scenes to get it done. It's not something that's going to basically change anything drastically. It's just going to do better plumbing and better communication between the payer and the provider.
Gotcha. And a lot faster. So all those things would get dropped. A lot of those are people like the fax or this or that to pick it up, resubmit it. And it's just really accelerating those processes that would be dropped as well from the human, correct?
Yeah.
Cool. All right. Well, should we go to risk assessment? That would be pretty interesting. I think I would love to know more about how generative AI could help with risk assessments.
Yeah. So when you look at risk assessment, there is, especially when it comes to Medicare, Medicaid, there is something called HEDIS scores and star ratings. So the star ratings is something that's coveted by most payers because the higher stars you have, the more reimbursement you get. So 5-star rating means you are the top-notch payer and you're going to get the best reimbursement from the government. And the way you achieve that is by showing a bunch of metrics and showing that you are kind of meeting all the metrics. And how you can meet all the metrics is basically by looking care of your high-risk patients. You do that by analyzing their claims data, running analytics on top of it, and ensuring that they are getting the required treatment they want. And if they have any pre-conditions, then they are basically getting the corresponding screenings. And you're also going to analyze the medical records using AI to make sure that when you see anybody high risk, you proactively start reaching out to them through a program. So you don't wait for this condition to develop, but if you look at the medical records and you figure out that there's a pattern that you're seeing and probably the patient may develop a particular condition, then you can basically stop that from happening. Readmissions is a classic example, because if you look at it, a lot of money goes into readmissions, and if you can prevent readmissions, you can basically go up in the star ratings pretty quickly. So stuff like that, that's where AI is basically used. And generative AI can put a face to all these things and make it seamlessly available to the people who are kind of driving these conditions.
So with risk assessments, so the biggest area, if I'm hearing you correctly, is the biggest cost next to pharma for the payers is the hospitalizations, the readmissions that are avoidable, unnecessary. So you see that as a huge area to proactively, with whatever's coming in, those data points, whether it be then to immediately put in triage or nurse care managers or however be to reach out proactively to the members. That's how I'm hearing you correctly, correct?
That is correct. Because if you look at it, whether they are taking the meds properly, whether they're going for the screenings properly, whether they're adhering to the schedule properly, if you can kind of get these things analyzed and run some models, and then you can basically start reaching out to them, start coaching them, and making sure that they are healthy, and you avoid the readmissions, then that's basically going to save a lot of dollars, both for the patient as well as for the payer. So.
Well, I guess we're pretty close into population health management. So maybe you could help walk us through some generative AI opportunities in population health management.
Yeah, population health of late has been pretty fun. I mean, it's a pretty important topic, especially with the health equity. What everybody's trying to do is making sure that the population that they're managing is well served and they are taken care of and they're getting the required care. So what they do is, I told you earlier about the FHIR format, right? So once you standardize the data and make it available in a format that's interoperable, you can run data analytics on top of it. And then you can identify your high-risk population, and then you can basically make sure that they're getting the required care. And generative AI is going to help you in a big way to basically start conversing with your system, as opposed to you drilling deep into each of the parameters. So what it's going to do is it's going to understand your entire corpus of data, and then you can start asking questions to it like you ask for a real human who has gone through the report. You can say, you know what, pick me the top 20 patients who are at a high risk for diabetes from this particular practice. Then it's going to show you who are the 20 patients. And then you ask details on that, saying that, okay, so if there is a case, are these patients taking their medications? Then it's going to tell you yes or no. And then you can basically start asking more questions for them, saying that, what about the health metrics for this particular group? And it's going to answer a question. So what generative AI is going to do in the population health space is, once you have your data interoperable and you have it ready for analytics, it can kind of go through the data and let you converse with the system, and you can take actions, call to action based on what you want to do.
So I'm thinking of like SQL developers, other database, analysts, senior data analysts. Are these roles that really are going to be using these sort of solutions? Is there rightfully fear of roles being, displaced because of these technologies? It seems like that is about as accessible to get big wads of data, sloughs of data, extremely easily accessible and understandable. What kind of roles do you see that might be displaced that are current in healthcare with these solutions?
More than displaced, I would say realigned, because if you look at it, when cloud systems became popular, we had this new concept called infrastructure as code, which means you no longer have to basically set up your databases or servers. You can write code, and that will basically start spinning up systems, which means the old database administrators and the server administrators, they started learning this technology, or basically this solution, how to spin up systems, and they basically started creating infrastructure through code. So basically they retrained, and now they started maintaining all the systems in the cloud. Similarly, if you look at generative AI, it can basically converse with the system and give you the output, which means the people who are kind of creating these SQL queries, they will start training the model through prompt engineering. They will basically align on the new paradigm, and they will basically start doing a job differently, which will basically lead to more efficiencies in the chain, pretty much.
Do you see any concern with leadership, executive leadership that just doesn't know these technologies, hesitant, even though they can be very much more efficient and effective to embracing this?
I think it's going to be the combination of two things. It's the first more advantage because if you look at all the major players, if somebody is there and they are going to basically make a press announcement saying that we are releasing this new system which is going to do X, Y, and Z, that means others have to basically catch up because the point is they have done their homework. They're saying that this is what they're going to do and these are the metrics they have published. And it's like, who is going to basically make sure that they're not going left behind? So that's going to be the race if you look at it. And if I think the recent survey from McKinsey also said like 97% of the Fortune 500 CEOs felt that generative AI is something that's there in the priorities. So it's more like everybody understands it's a game changer and they want to make sure that they are coming up with the right use cases which address their corresponding industry and it leads to more productivity.
So where do you see us right now in this phase with generative AI adoption in healthcare and the payer space?
I would say we are just scratching the surface because even if you look at healthcare right now, the technology adoption is a little behind compared to fintech in the sense that we are kind of working on, as I said, a common standard, making sure the data is interoperable and so on. So the generative AI adoption is kind of, people are scratching the surface, trying to figure out how to leverage this technology both internally and externally. It's not just customer facing, but it could be like something that they can deploy internally to the enterprise as well to lead to increased worker productivity. So it's kind of being evaluated pretty closely. And there's a lot of innovation happening with respect to large language models, where it's being like everybody is coming up with their own large language model, which is going to help to accelerate the adoption. And once you have all the cloud service providers releasing their services, it's going to be pretty exciting.
Well, I want you to get more into the everyone's coming up with their own large language models. Are these health systems? Are these, I know you're in the payer space, but you work closely with health systems. I mean, of course, if you were able to, I know you have to be careful with certain proprietary customers, but if you could, it would be interesting from the payer and health systems if there's anything that you're seeing, because it seems like there would be great interest, just like first movers at competitive advantage with their own proprietary generative AI models, just like we've seen cloud right now. And we're still, I would imagine, and I'm sorry, this is a long question, but cloud is a huge opportunity within healthcare to cut back on cost and efficiencies, and a lot of these old legacy systems. So it seems like there's great opportunity. Love for you to share a little more about proprietary generative AI potential with alignment with the cloud kind of, and I'll stop there.
Yeah, so if you look at it right now, the large language models or the foundation models, they are being trained on a corpus of data across all domains and all industries. They are not limited to any particular industry or domain. So the startups, what they're doing is they're taking a specific large language model and they're training it on basically a specific area. For example, if you look at it, there's a model that basically looks at electronic health records and it knows how to interpret electronic health records. There's a model that knows how to look at clinical trial data and then interpret clinical trial data. So there are, like, if you look at healthcare field, there are LLMs which are being released across specific areas in healthcare, like, for example, for clinical trials, for electronic health records, text summarization within the healthcare space. So those are being basically done by startups, which take this data, train the model, and create customized model for healthcare industries. Similarly, that's happening pretty much across all industries. So the challenge would be to look at the model, and then a particular organization has to adopt the model for the enterprise and train it on their data, secure it, and ensure that that's basically helping them do their job much more efficiently.
So I guess anyone in the cloud loves generative AI. You can't have generative AI without the cloud. I mean, there's just so much data, right? I mean, I know this sounds like a silly question, but it's like, anyway, I'll stop there.
Yeah, yes, because I think it's basically economies of scale, right? So if you look at it, generative AI, if you want to train a model, as I said, you don't have to train the entire model. If you want to just train a subset of parameters, you need a really powerful CPU with memory and so on. So if you want to build your own system, it's going to cost you a huge amount of dollars. Instead, you're renting a system in the cloud. You're just paying, it's a pay-as-you-go model, and you pay only for what you use it. So let's say you want to use a really powerful NVIDIA Tegra processor for training your model, NVIDIA GPU for training your model. You can use it for 2 hours, and you'll pay probably like $100, $150. Whereas if you want to own that whole processor, it's going to cost you thousands of dollars. So that's where I think cloud comes in, because it brings in the economies of scale. And the most important thing about cloud is you only pay for what you use. And it's basically like a renting model. It's like Uber or Airbnb, where you just pay for the service and then you're done. You don't own it. So that way it kind of works out well.
So are there any applications that you're really excited about, bullish with the large language models? I know you're talking about clinical trials in different areas. It seems like there's so many different flavors coming out. How do you keep on top of it? What are you excited about?
I think the exciting thing would be, if you look at it, FHIR is basically the standard for healthcare, and the schema for FHIR, like the tables that you used, are also pretty standard. So something that lets you talk to the system and generate FHIR queries and get you the data seamlessly without you having to drill down into millions of rows to get the data, that'll be pretty exciting, because that will ensure that you're basically democratizing healthcare data and making it available seamlessly. Of course, security is a pretty big aspect of it. You have to ensure that the wrong people don't get their hands on the data, but that'll be a pretty big thing.
Are you mentioning now a possibility for multiple startups that have open AI FHIR, if you would? I mean, it seems like there's an area right there for opportunity for startups or for enterprise to capture that savings, or both?
Yeah, there are a lot of startups who are involved in the area. And in fact, there are customized large language models which actually address these scenarios. I think the challenge is taking the model, training it on your data, and securing it and making it available and making it scale. I think that's basically the challenge. So the whole point about generative AI is there's a lot of innovation happening, and it's basically tailor-made to the industry. But once it's tailor-made to the industry, you take the solution, you make it available for your own enterprise, and you make it in a secure way and scalable way. I think that's where the challenge is.
Yeah. Well, this has been a phenomenal conversation. I don't think we're finished. I know we have different times that we go. We don't have a fixed point. I feel like we're getting some robust discussion that our audience would really appreciate, because I think there's so much hype and so little knowledge, because there's just so much out there. And every day you see someone posting all these different AI or whatever, GI whatever, .ai, right? Everything's .ai. So, especially coming from you as a cloud solutions architect, some probably many years, I'm sure you started out coding, you probably still do some coding. I want to make sure that I'm uncovering as much as I can, Lox, from your knowledge share, anything that's come top to mind as we've been, moving through the cloud generative AI today.
I think the one thing is, if you want to get your hands dirty on any of these, it's pretty accessible right now. You can go to pretty much anywhere, sign up for an account, and start playing with it. It's pretty simple. And the way all the providers are working towards democratizing it is a pretty commendable effort. And responsible AI is also one more thing, as you said. You touched upon that as well, because, as you said, the technology is pretty powerful, but I think with great power comes great responsibility, right? So you have to make sure that it doesn't fall into the wrong hands, and how we can make sure that it's secure and it's helping for the efficiency of the enterprises.
Well, man, this has been a great time. I really appreciate you coming on. We're only as good as, not me, as our guest, our special guest, and you've been a special guest today. I really appreciate your knowledge on generative AI in the Payor space, and all the work you're doing. And you will, when I post this podcast, you'll be able to see more of Lox, how to reach him, how to connect with him, because that's what this is about. It's really about others, sharing with others, building a community, and learning from one another. So before we send off, Lox, is there a last minute send off if you want to wish your cousin or whatever, anything you want to say, any thoughts? We're all ears.
Yeah. Thanks a lot for having me. It's been a great conversation. As I said, we are just getting started, so pretty exciting, and would like to see where we are with generative AI sometime next year. I think we'll be like, when we discuss next time, probably we'll be like seeing a lot of things that we spoke about being implemented and already in place. Maybe prior art becomes so seamless. Let's see.
Cool. I love that. Friends, it has been a great journey today on Planetary Health First, Mars Next. Follow us for more on Planetary Health First, Mars Next. Until next time, peace be with you.